Hello YouTubers, I've been wanting to start on the lighting and electrical aspect of the layout for at least 6 months now, but I was a bit overwhelmed. In fact, I'm kind of clueless, and if you're watching this video, you're probably clueless too. So I've started this new segment called ElecTrainics, and today we're going to start with the absolute basics of LED lighting. Light emitting diodes, or LEDs for short. Pretty amazing, find them everywhere. They do have some advantages over incandescent bulbs. Low voltage, low heat and low cost, which is ideal for us modelers. There are some disadvantages, unfortunately. I mentioned low voltage. If you apply too much voltage, they just pop. And also, they are polarized, unlike an incandescent bulb. I have an assortment of LEDs below me, so we'll go through each one, see what their limitations are and where we might use them. So these are the most common LEDs you'll find. These are 5mm LEDs and 3mm in various colours, but they do run in slightly different voltages. For example, I think the blue might only require 1.8 volts maximum, whereas the white requires or can take up to 3 volts. And on the subject of these LEDs, I said before they were polarized. If you notice, the legs are different lengths. Longer normally signifies positive, so make sure you hook up your positive to that side and not the other side, or they will not work. And you would use these in things like locomotive headlights and maybe inside buildings and anywhere that you've got plenty of space. Because if you don't have a huge amount of space, you might need something like this. These are fantastic. These are micro LEDs. They do the same job as them, usually get the same sort of voltage, but they are absolutely minuscule with very, very fine wiring. So you could use these in places that you don't have space, like ditch lights and locomotives, maybe little street lights, that kind of thing, because they would be way too big for just a little subtle street light. They're great. We will test all this out later. These ones are pretty much the same as those ones, but they're pre-wired. But these are 12 volt. I'll explain how that works later. But that saves a lot of hassle if you just want to wire your LEDs straight in without adding resistors, which again, we will discuss later on in this video. And then you've got these LED strip lights, which are very common. People put them inside their PCs, under their kitchen cabinets, everywhere. Really, really inexpensive. They usually come in a row like this. I was a wee bit confused how these worked, but now I know, and I'm going to pass that information on to you. The very first thing you want to do with your LEDs is make sure they work. No point wiring these up to your project only to find that they've blown before you even start. Now, there's a couple of ways you can test them. The very basic way is using one of these 3 volt remote control batteries. I guess you would find them in your car remote. And they'll work for everything without blowing them. If you want to upgrade, get yourself one of these LED testers. You basically put the LED in here, and this is also 3 volt. It does have a 9 volt battery, but it's restricted to 3 volts, and it just makes it a lot less fiddly than trying to wrap your LED around this. For example, positive goes to the positive side of the battery, onto the negative, and it lights up, as opposed to doing it with this, which is going to be much easier. Let me show you. This is pretty simple to use. Now, this actually has a milliamp meter as well, which I have no idea how it works, to be honest. All I know is voltage, and this kicks out about 3 volts. So, as I said before, positive, negative, positive on the top. I'm going to start at the lowest setting. That works fine. I hope you can see that. Little white one, 3mm white one I mean. Exactly the same. Long leg in the top. Lovely. Not the best connection in this little Chinese meter, but it does the job. And the same with all the rest. Now you might see the different colours being different brightnesses, like that for example. We could move this along. The higher the milliamp, the brighter that'll get. Like that. You see that? Same voltage, different milliamp. Again, really don't know the difference in the milliampage, but anytime you buy these things, it will tell you what the milliamps are. And I think the red one is relatively bright. Let's find out. Long leg in the top. Move the milliamps up, brighter. Still 3 volts, higher milliamps. And that's how they all work. Pretty basic stuff. It's a nice little tool to have in your arsenal. And you don't generally risk blowing your bulbs before you start. So that's all well and good. There are another couple bulbs here that I didn't point out. These are actually flashing LEDs. Should work exactly the same way. Long leg in the top, flashing away. Very nice. I have no idea what makes them flash. All I know is I bought them as flashing LEDs and they flash. I wonder what happens when we move up the milliamps, if it still flashes. Oh, it does, and it's brighter. So, milliamp just seems to make whatever voltage you've got brighter. If anyone knows more, well, everyone knows more than me, leave a comment on the milliamp and how important it is when you're wiring these up. Now, the one thing I can't really test with this is the micro LEDs. They're just way too small. So let me drag one out. Oh my goodness, it's like micro spaghetti. Let's see if we can get one out, and we will try it just with the little battery. I think you'll be amazed at how bright these little things are. Extremely awkward to test though. There we go. Just trying to squash those connections in the end, but you can see that it's, considering the size, more than adequate for the likes of a ditch light. Love these things. Now, we can't actually test these with the LED tester because I mentioned before, these are 12 volt pre-wired. What does that mean? Well, your basic model railway runs anywhere from 12 volts to maybe 18. Like I have a DC section on my track running 18 volts. So obviously one of these little LEDs, the 3 volt LED, is just going to pop. Actually, let me show you what happens when we hook up the track DC power to one of these LEDs. I'm going to use this breadboard for this particular experiment. You don't need to know anything about this at the moment. I will cover it in a later video. It really just makes it easier for me to hold the LEDs in place. So these 2 wires, positive and negative, coming from my track controller, DC track controller, 18 volts, okay? These lines here, the vertical ones you see, each line is connected to each other. So if I just put in the negative there and the positive doesn't need to be right next to it. Basically everything now in this line coming up there from the black, they're all connected, and these ones are all connected to the red. So positive there, negative there. So if I stick a bulb in, again, long leg positive goes on that side, there, negative there. Okay, just makes it easier. I don't need to hold things while I power things up. So let's put on my track power. Did you see it flash there very briefly? That's because my track power was set too high. That LED, RIP, one down. So this time I'll start with the track power at 0. I'm going to use a yellow one this time, long leg in the positive, short leg in the negative, and we'll gradually turn up the power. This is DC power, okay? So that is probably about 1 volt. Starting to get darker, darker, and it's dead. Okay, that bulb is dead. So you cannot use track power straight to these LEDs, and that's where you need resistors, which look like this. Now, I know they all look the same, but they all have different levels of resistance. And I have made a sort of basic calculation on the amount of resistance I require. Let me explain that further. My DC power controller pumps out around about 18 volts. This little LED, it can only take around 3 volts before it pops, which means we have an excess of 15 volts that we need to make disappear. And that's what the resistor does. It basically sucks up all the extra voltage. So we need to suck up 15 volts. And here's the way I've calculated it, okay? These resistors range everywhere from, I need my intelligent glasses, they range from 1 ohm resistance all the way up to 10 million ohms resistance. That's a big variation. So the way I've calculated it, do not quote me on this. If you blow up your stuff, don't blame me. There's online calculators to do it properly. So I've calculated in my little head, 15 volts, divide that in half is 7.5. Let's call it 8, just to be on the safe side. Add a couple of zeros is 800. So I've calculated, again, this is just me, that I need a resistor value of 800 ohms, okay? Now what I've discovered with these pre-wired bulbs, LEDs, generally they have a 1000 ohm resistor just to be on the safe side. Now you can add the 1000 ohm, no problem at all. It just means that your light is not going to be as bright as you like. But again, these guys are erring in the side of caution. But I'm going to stick to my 800 ohm resistor and see what happens. So I'm going to dig through this pile, see if I can find an 800. I'm not going to go lower than 800, and these are not exact values. So if I find something 800 or slightly above, we're going to attach that in line before it gets to the bulb. And hopefully it won't blow on full power. Well, I dug through my assortment of resistors and I could not find one at 800. It seems to jump from 680 up to 1000 ohms. Maybe that's why they all use 1000 ohm resistors. Maybe they don't make something in between 680. No point using a 680, I know it'll just blow. So let us just stick to using 1000 ohm resistor. So what we need to do, we need to put this resistor in line somewhere. It doesn't matter if it goes that way or if it goes that way, and it doesn't matter if it goes on the positive side or the negative side, as long as it's somewhere in the overall circuit. So let's see now. Let's put the positive here. Let's get the resistor connecting this power line, say up there, and we'll bring it down to just over there. Doesn't matter where at the moment. Next thing we're going to do is connect the bulb from this line here. Remember all these 5 little holes here, they're all connected. And we will be looking for the positive side. So we'll go from that one to that. Let's go up there, okay? Because positive, okay? Negative then, we should be able to hook this to this side of this line here. And now we should be ready to try our little circuit, okay? Let's turn the power down for now. Switching on the controller. Controller is on. We are lit. Let's see if we can go full voltage. It should stay on with 1000 ohm resistor. It shouldn't pop. Okay, we are at 18 volts or roughly 18 volts coming from our transformer. And it stays much the same brightness all the way down to pretty much off. So I think with a slightly lower value resistor, it would come on a wee bit earlier, but it also might pop. Bear in mind, this DC controller is way overpowered. Most DC controllers are only about 15 volts. And that is what the resistor does. Let's just try a different bulb while we're here. I'm actually very keen to find out what happens if we try one of the flashing bulbs, because they do rely on a very specific voltage. So we'll try the red. Again, we're coming from one side of the resistor, positive, into the negative black wire. Let's turn up some power. Oh, right, you see how it's constant there? It flashes really quickly there. It's all over the place. So I think in order to do a flashing red, oh goodness. So the flashing red is only flashing when it's at full power. Or let's see, what about over 3/4 power before it flashes constantly. So that does require a very specific resistor. So that's your basic LEDs and why you need resistors, but what about these strip lights? They work pretty much the same, but they're a little bit different. So the strip lighting normally comes in a roll like this, and you've got two wires, and it works similar. You know, you would hook up your positive, your negative, stick your red line in there and your black one in there, like so, like we did with the LEDs, and then you turn the power on and it all lights up, okay? And that's maxed out 18 volts. Even though this is a 12 volt system, it kind of shows that my power controller is probably not pumping out 18 volts. Turn the voltage down and we're good. But here's the really cool thing. I'm going to do something which looks kind of crazy. But I'm going to cut this off right there. Okay? And then I'm going to plug it back in. Positive in the positive line, negative in the negative line. Turn up the power. Still the same brightness. In fact, to take it even further, I've not ruined the rest of this. If I hook up the positive to that one there, negative to that one there, and with my third hand, should have thought this through a bit better. Let me turn the power up to halfway on the controller. When I touch that there, all my LEDs are lighting up again. So let me explain how that works. Let me turn my noisy controller off. If you take a close look at these, okay, you've got three LEDs. 1, 2, 3, and then you've got this little copper terminal here with a line through it. The little line signifies that you can cut that. And then you've got 1, 2, 3, you can cut it again. So basically, as long as you've got them in threes, because each three LEDs are resisted, they've got a little resistor right there. That little resistor takes care of those three bulbs. So the next three, little resistor, next three, little resistor. So as long as you make these in sets of three, so you could have 3 or 6 or 9, and if you get a big long passenger coach, it might be that long. So you could cut it again on the little line. They are polarized, as I said before, positive there, negative there. You can easily solder your little wires onto the end of this and go down to your track pickup. And it's as simple as that. That's how LED strip lighting works. They've got this, you peel this backing off and you've got glue in the inside and you stick it to the roof of your passenger coach and you've got a lit coach. Pretty basic stuff. Obviously, there's more to it than that. Because what happens if you want to run your DC train in reverse? The positive negative is reversed. Let me show you. So stick our track power on. We start our train up. Faster and faster, lights come on fairly quickly and they stay on. But what happens when you want to go in reverse? Let's switch to reverse, turn the power up, and we have nothing. Back to forward, we have lights again. That's a problem. But don't worry, there's a fairly easy solution to it. Well, it's easy for me now because I've been looking into it for the last 2 months. There's all sorts of things you could do. You could install 2 strip lights and wire one in reverse, but as I say, much easier ways to do that. Now, this was all based in DC power. I will be going into AC or, for DCC type stuff later on in this series, but I just wanted to start with the basics. On the next episode, we are going to be installing a strip light into a passenger coach, and we're going to wire it for working in forward and reverse without having to have 2 strip lights, okay? And we're going to be using a bridge rectifier. Never used one before, but after extensive research for minutes, I think it's fairly basic and anyone can do it, as long as your hands aren't too shaky because the parts are pretty small. Anyway, I hope that helped ease you into the whole LED thing and explain how they work. Basically, they're low voltage, you need resistance so they don't pop, and they're polarized. That's pretty much it. We will delve deeper on the next video. Thanks for watching. Bye for now.